Now that hormones are behind us and we've kind of gone through the process of ovulation and that entire that entire cycle of that 28-day cycle, we left off with this particular image. What just happened with that ovulation event is the release of that oocyte with follicle cells. It doesn't go alone. And what it has to have happen is this fallopian tube, or this oviduct, it has to sweep it up. It has to pull it in. So it splays out at the end here in what's called the infundibulum. I've seen it kind of compared to the end of a trumpet. And so you've got an increase in size. And then it doesn't end just smooth, it ends in what are called fimbriae, these little finger-like extensions. The lining is going to be ciliated, and those cilia are going to beat like this to set up these little microcurrents to hopefully pull that oocyte and the follicle cells in. When fertilization takes place way up here. It doesn't take place in the uterus. So let's talk about the uterus for a minute, some of the anatomy, and we'll work our way from the internal genitalia to the external. The uterus itself, some people call it a womb. I don't know where the term came from, but it has essentially 3 different layers of tissue. The internal lining is endometrium. Makes sense, endo, inside. Then, thick to that is the myometrium, muscle, and then we've got the perimetrium around the outside. Endometrium, myometrium are going to be a couple that we'll address here. Then it tapers down into what's referred to as the cervix. So when you talk about dilation with a pregnant woman, how dilated is she? It's all dealing with what's the width of, some of the time called the birth canal, or a portion of the birth canal, or the cervix itself. And then below that, the acidic vagina, where those sperm from a couple of videos ago should have been deposited if you're going to successfully have a pregnancy. Those sperm half go up the wrong tube. A huge number of them are killed. The alkaline secretions from the seminal vesicles don't keep all of them safe. So there's not a large amount of sperm that actually makes it to the ovulated egg. Now the myometrium and endometrium, this myometrium, this real thick tissue, is all muscle. And it's muscle because at some point, if you're pregnant, you're going to have to, unless you C-section and surgically have the baby removed, you're going to have to be able to push that out. So yeah, this myometrium plays a really, really big role when it comes to birthing. But another big role that it plays, that you've probably experienced as a female, even if you've never been pregnant, has to deal with the endometrium. If fertilization in a pregnancy occurs, what's going to happen is that now diploid cell, because fertilization will have happened, we'll talk about this in a little bit more detail in a couple slides, but it's going to implant. And what it's going to do is develop what's called a placenta. Now, a couple things with the placenta. Let's suppose you are pregnant. The placenta forms, which is the interface between a female and her new developing child, her fetus. What that placenta is going to do is it's going to then secrete a hormone called HCG. And what HCG stands for is human chorionic, and here's the kicker, gonadotropin. An HCG, human chorionic gonadotropin, is going to keep essentially the corpus luteum alive. Go back from that last video. We looked at the corpus luteum slowly dying and then progesterone going down, and we go into the entire ovulatory cycle again. No, not if you have a placenta. HCG keeps it alive. Also, HCG is what's used for pregnancy tests. I do piano stick and see whether it turns plus or minus. What it's doing is it's testing for the presence of human chorionic gonadotropin. If you have a placenta, you produce HCG and you're pregnant. And that's why that little plus or minus comes up on the pregnancy test. Now let's suppose no pregnancy occurred. No fertilization occurred, let me put it that way. Here's another selfless thing that mom does, that potential mom does, that females do. This endometrium is very, very vascular because this placenta, this new pregnancy, has to have a good, healthy layer of tissue to develop on. So if that layer of tissue, that endometrium, is 2 weeks old, 3 weeks old, 4 weeks old, females decide, not consciously, but it's too old. If I have a pregnancy now, I don't want the pregnancy starting and developing on old tissue, old being 4 weeks old. So what females will do, they will break down the entire endometrium. And this breakdown happens on day 1. Remember when the anterior pituitary started kicking out the FSH? On day 1, this is broken down and it's expelled vaginally via the myometrium. So those muscles are going to work at pushing all of that vascular tissue out of the body. It's the myometrium that causes menstrual cramps. And females that I've spoken to, they're like, oh man, my cramps are killing me. It's because of the myometrium. Once that has been expelled from the body, that being the endometrium, she'll rebuild it. So next month, next time around, that next 28-day cycle, after day 14 in ovulation, if a pregnancy occurs, this stuff is brand new. It's fresh, it's only 2 weeks old. So it's just another selfless thing that females do when it comes to a pregnancy and sexual reproduction. Now this is all internal genitalia. These are the internal genitals, and there's more than just internal. The vagina itself is internal, but there are also external anatomical structures as well. When we take a look, we've got essentially 3 things that we're focused on. Some will include 1 or 2 others. The clitoris or clitoris, you can say it either way, and then the labia majora and the labia minora. Now the 2 images that I have, you might think, well, wait a minute, not all of them look like that. No, they don't, because we're highly variable. What you're seeing is right down here through the middle, what's called the clitoral or clitoral hood, which then extends into the labia minora, which you can't see. This individual has very developed labia majora and not very developed minora. And what the majora and the minora are essentially there for is, for one aspect, is protection of the vaginal opening. So these are essentially tissue folds or fatty tissue that helps to make sure that the vagina isn't just a full-on open access to the body. If we look at it like this, there's that clitoral hood that I mentioned, the labia majora, which is much more fatty, and then inside the labia minora, which on the last one you essentially couldn't really pick out. The vaginal opening itself is here, and the urethral opening is essentially right next to it. But I mentioned that it's primarily for protection. There's another thing that they're all collectively involved in, and it's sexual stimulation, especially the clitoris. The clitoris itself comes from the exact same tissue that would have become a penis in males. It's got the same nerve endings, it's got the same nerve beds, so it's very essentially responsive by increasing blood flow. It's got its own spongy tissue. So it's more than just protection, but this is what's referred to as external genitalia. And the mons is this area right here, the mons pubis, that is essentially right under the pubic symphysis. Sorry, I was drawing a blank on my skeletal system. So we've got internal, external, and essentially if all works as planned, what we want to have happen is this. And we get back to making a baby, making you. Now this is idealistic. This isn't what really goes on. What happens because of the ejaculation of a couple 100 million sperm, most of them are spermatozoa, most of them dying, many of them making it to that nice little egg that's surrounded by follicle cells. It looks more like this. So we've now got a competition. We've got to figure out how does fertilization happen. So we played around a little bit with the male animal. We've played around with the female animal, and I think you can see how there's similarities about how different they are. Now we need to take a look at fertilization. Up in the oviducts, hopefully a pregnancy occurs and we have an implant in the endometrium. At least that's where I'm going with this next video. So I'm going to put you on hold. I'll be right back.